recording.
Thank you, Dawn and Cindy. So let me just share my screen. Okay. So thank you guys all for coming to our March meeting. The announcements are the same as they are every month. We would love if you joined the board. If you are interested, you can contact me at president@vancouveraudubon.org, and I will let you know what can be done on the board, and I will get you in contact with people who can help. So for field trips, we have a lot of field trips coming up. Most of them are led by Randy Hill. So there's a field trip to the Yakult Burn State Forest on March 4th. So that's this Friday. That's Randy Hill. And on Saturday, March 19th, Cindy is leading a trip to Beacon Rock State Park. And then on Friday, March 25th through 27th is the Othello Sandhill Crane Festival. So that's in Othello, Washington. So it's a bit of a drive out, and this Sandhill Crane Festival happens every year. So it's not officially affiliated with Vancouver Audubon, but it is a fun festival to go to, and Randy Hill will be going to that festival. So let him know if you'd also like to go to that festival. And then this is way out, but there will be a Grays Harbor County pelagic trip. So a pelagic trip is going out into the ocean. So pelagic means open ocean, ocean environments. And there are lots of birds you can see out there that you can't normally see on land. So if you're interested, again, please contact Randy Hill. So I will post these emails in the chat. Great. So our speaker is Mary Coolidge. Mary is a bird safe campaign manager for Portland Audubon, and she's going to talk to us about how to make our home and businesses safer for birds, including the Lights Out program. So I'll give it over.
Hello, greetings. Let me get my screen shared here. Give me a shout if you can't see my screen. And hopefully
Got it. Looks good. There you go.
Fantastic. Okay, great. Yeah, so thank you, Sam and Dawn, for having me here tonight. And thanks to everybody who's joining us as well. I'm going to talk tonight about a couple of urban hazards for birds in the built landscape. I'm really going to focus a lot on light pollution, but I'm going to talk a little bit about collisions just briefly because they are a related issue to light pollution. But, you know, our cities are really functioning urban ecosystems, especially places like Portland and Vancouver that I think have a lot of amazing habitat. We're at the confluence of the Willamette and Columbia rivers. We have really rich forests and soils, and we have over 220 bird species that are regularly documented in the area. And so we have our urban bird populations that spend the entire year here. We have birds that are migrating through. We have urban wildlife populations. And what can we do to make sure that we're really helping those urban wildlife populations and our urban ecosystem function as well as possible? I really want to get folks thinking about the night as habitat. We tend to really think so much more about daytime because we're humans and we're diurnal. But night is very important habitat, maybe even just as important as diurnal habitat. And hopefully folks are picking up on something interesting about this image here. Dawn got it right away when we did a test run earlier tonight. So this is a photo by Haroon Mamadinovich. He is part of a twosome with Gavin Heffernan. They work on something called the Skyglow project together, and they take photos of Amazing night skies all over the US and also all around the world. And this is an interesting photo that they did, which is a composite of a photo of downtown LA and of a brilliant night sky where you can see the Milky Way. And obviously you can't see the Milky Way from downtown LA or from downtown Portland or downtown Vancouver. But I like to use this image because I think it helps us imagine and remember that there's a sky full of stars up there every night of the year, if only we could draw back this curtain of light pollution that we all live under. So a real quick overview of what we're going to do tonight. We're going to define light pollution and talk about why we need to reduce it from the standpoint of ecological health because of its relationship to window collisions, human health, sleep and safety, equity considerations as well, energy and cost ramifications. And then we're going to talk about solutions or best practices in lighting design that have been developed to reduce light pollution. And we're going to talk about how to have good lighting. So using it only when and where we need it, really thinking about the amount and the timing of our lighting, thinking about color temperature, warm versus cold, and we'll get into that, thinking about shielding our lighting and thinking about smart controls. And then I'm going to talk about our Take the Pledge to Go Lights Out program. So I'm going to start by taking us way back. For 4.5 billion years, there was no artificial light on this planet, and biological systems in large part evolved under bright days and dark nights, these regular cycles. And that set up almost all biological processes to be governed by these light-dark cycles, including ourselves, including humans. The only reason why I give a little bit of a caveat about that is because we know that there are things that spend their entire lives in caves or underground or in the soil or are blind. And so in some cases, they're not going to be subject to circadian rhythms and the master clock the way that the rest of us are. But in large part, light-dark cycles are the master clock on the planet, and they drive our circadian rhythms. So this governs sleep patterns, eating, foraging, migration, if you're a migrant, breeding, leaf drop in plants, you name it, it's governed by circadian rhythms. And here's where we are now. Here's where we were in 2011. This is a NASA photo, satellite photo from 2011. So obviously we're about 11 years past this and things haven't gotten any better. I'm sure you can all imagine. This just illustrates how we have, in the last 130 years or so, since we introduced artificial light to our streets, we have really started to light the night on a global scale. And today, most human beings live in urban or suburban areas. And in those places, we are awash all night long from things like street lights and billboard lighting, sports field lighting, in some cases, security lighting, parking lots, many of them empty all night long, right? So this is not benign light. This interrupts our circadian rhythms, you know, again, in ourselves and also in birds and mammals, fish, amphibians, reptiles, invertebrates and plants. So really not benign, it has impacts. And here's how we get there. So this is what that light looks like on the ground. We have lights that are poorly aimed, that are unshielded, that are too bright, that are on all night long. They're on when we're not using them. And, you know, we get to a point where I think we don't even know what it would be like to not live in this eternal lightness, right? I mean, how many people recognize this photo in the upper right-hand corner where you see an absolutely empty parking lot and it's just illuminated to the hilt? This is something called the Bortle scale. Maybe folks have seen this before. This is a scale that was developed in 2001 by a guy named Bortle. And this is a tool to help amateur astronomers evaluate the relative quality of darkness at their observation locations. So this scale goes from, on the right-hand side, a #1 excellent dark sky site or world-class dark sky site, over here to the left, an 8 or a 9, an inner city or city sky. And you can see that as you read this from the right to the left, you can see the loss of stars as you see the encroachment of light pollution. Over here on the right, I have a bunch of locations in Eastern Oregon named, but I'm sure that there are corollaries in Eastern Washington that have these amazing world-class night skies. And then when you get over here to the 7, 8, we have cities that are kind of on the cusp of this red and this white light pollution level. So Portland is there, Vancouver is there, Seattle, LA, San Francisco, even Eugene and Salem show up over here. Obviously, there are some places you can be in the city where you have better views of the night sky than if you're right in the downtown area. And this is more or less what that looks like on a map. This is the New World Atlas of Night Sky Brightness. It's an excerpt. That's a global map of light pollution that's based on infrared imaging. This is obviously just an excerpt of the United States, but similar to the Bortle scale, warmer colors like reds and whites indicate higher light levels, more light pollution. Cooler colors like blacks and grays and blues are lower light levels. Green is kind of somewhere in the middle. So this shows a pretty staggering picture of what light pollution looks like in the United States. Obviously, here in the West, we're way better off than they are east of the Mississippi. We still have a lot of pretty decent dark skies in the West. But if you look up here to the Pacific Northwest, you can see that we have a nice concentration of light pollution along the I-5 corridor. One thing I want to mention is that when these researchers overlaid their light pollution maps with, or rather their light pollution maps with census data, they found that 99% of people in the United States live under light polluted skies and 80% live in places where they can't see the Milky Way from home. So we're really divorcing ourselves from our deep human history of having a connection to the night sky. So yeah, in the West, we're a little better than in the East, but this is just a close-up of what it looks like. The I-5 corridor, essentially from Eugene all the way up to Vancouver, BC, is an almost continuous band of light pollution with, you know, a few little bits of interruptions, but you really have to get over into Eastern Oregon and certain places in Eastern Washington and over into Nevada and Idaho before you get into some better dark night skies. I want to mention briefly, I'm also on the board of the International Dark Sky Association Oregon chapter, and some of my colleagues on the board are working on a project mapping changes in light pollution levels in Oregon over time. So each of these yellow dots here, or stars, is the location of a sky quality meter that is installed. Some of these have been operating for up to 2 years at this point. We have over 30 stations now distributed around the state. And in almost all cases, these are documenting rising light pollution levels. Some of them, you know, Observatory in Eastern Bend is looking at an almost 11% annual increase in light pollution. Aubrey Butte also in Bend is looking at almost 10%. Most places are seeing a rise in light pollution with a few exceptions. And I just want to mention, I'm guessing that Washington is probably in a similar state. Most places are seeing a rise in light pollution. We are living, after all, in the era of LED conversion. I'm sure most people have probably noticed this global wave of conversion from high pressure sodium, or our old yellowish lights, to LEDs. LEDs are great. They're energy efficient. They're really long lived. They're relatively low maintenance. And it was predicted that these were going to reduce global light pollution. Unfortunately, that's not what we're seeing happen. We're seeing a rise in global light pollution of, on average, 2% per year. As I mentioned, we're seeing some places in Oregon that have an 11% rise annually. So obviously there's a real range here, but we're seeing light pollution levels rise. And this is in part because of the kind of LEDs that we're using, and in part because LEDs are so inexpensive to run that people are using more of them. So they're installing, you know, as Americans, I think we tend to think more is better, right? Especially if it's cheap. So let's install more lights. But part of the problem is that early generation LEDs were all this thing called blue rich white light. That was just the first kind of LED that was developed. And these are essentially daylight mimics. So they're great for use during the day. They definitely tell your body that it's time to wake up, be alert, get some work done. The thing about this kind of lighting is that it emits this spike in the blue portion of the wavelength spectrum. It peaks at about 450 nanometers. This kind of light scatters more readily than longer wavelength over here at the redder end of the spectrum. And that spike at about 450 nanometers up to 480 nanometers happens to be the peak sensitivity area for birds, mammals, amphibians, fish, and humans. So basically all vertebrates are especially sensitive to this kind of light. And what this light does is it suppresses melatonin secretion. So it makes it hard for you to sleep, right? The American Medical Association came out with a report in 2016 when they saw this coming down the pipeline, and they warned that this kind of light may increase the risk of certain kinds of cancer, breast cancer, prostate cancer, diabetes, as well as cardiovascular disease in humans, and that it can also be associated with dangerous glare and even retinal damage. So their recommendation to municipalities in this report was that they avoid installing this kind of light in exterior applications, particularly streetlights, because that's where we're seeing a lot of these conversions. And these days, ecological light pollution is a really pretty huge and growing field of study. Ecological light pollution, or rather light pollution in general, was originally the complaint of astronomers, but these days more and more attention is being paid to the impacts that light pollution is having on ecological systems, because ecological systems are incredibly complex. And when we introduce artificial light at night, we are impacting the entire carefully choreographed system that has developed over millennia. Night is actually habitat for, amazingly enough, 70% of mammals, 90% of amphibians, 60% of insects, all bats, essentially. And things that can result from light pollution include confusing celestial navigation in some species. Light pollution can cause either disorientation or misorientation in nocturnal movements of certain animals. It can attract some animals and repel others, can impact predator-prey relationships, can actually extend the activity of some diurnal species into nighttime hours, which can have kind of costs and benefits for them, but is definitely messing with that careful balance in the ecosystem. And obviously, it can also skew the timing of all of these circadian rhythm-driven systems like breeding, nesting, migration, foraging, bud burst in plants, leaf drop, things like that. There are today hundreds, if not thousands, of peer-reviewed published papers on the impacts of light pollution. Everything looking from individual species in a paper to looking at entire ecosystems. And the truth is that truly none of it is good news. I could show you 300 titles of peer-reviewed published papers on light pollution impacts, and they would all be bad news. Okay, so let's dig into some specifics. Most birds migrate at night. We have about 630 terrestrial species of birds in North America, and 70% of those are migratory. Over 80% of those migrants actually migrate at night, even if they're diurnal species. So this is a gross generalization because, for one thing, migration is not all that well understood. It's definitely a developing science, and different species migrate differently, but really generally, birds will take off about 30 to 45 minutes after sunset, and they will watch where the sun went down below the horizon, and they will look for Orion and the Big Dipper, and they will orient themselves in the direction they're heading, and they will fly all night long if conditions are good. And the reason that they're flying at night is because they can preserve daytime hours for foraging, they can avoid diurnal predators, the atmosphere is less turbulent, and also because they're using the stars. I mean, they have redundant systems for how they're mapping their way, but they are using stars to navigate. And so that's another reason why they're going to migrate at night. And as I mentioned, they'll fly all night long if conditions are good, unless and until they come into areas where there's a lot of light pollution, and then they can start to get into trouble. So this is some research that was done on the Tribute in Light in Lower Manhattan, which has been illuminated one night a year since 2002. And Audubon Society of New York City and other folks started to notice that when these spires were illuminated, and these spires send light 4 kilometers up into the sky, they started to notice that birds were getting entrapped in these spires of light. So all of these white lines and dots in here, each of these is a bird. And what they're doing is they're just circling in that light and they can't get out of it. So they negotiated with the folks that are running the Tribute in Light, and they have those extinguished periodically throughout the night in order to release those birds from that force field that they're being held in. But they started to really do some focused research on this. And what they found was that when the Tribute lights were off, and I'm going to direct your attention up here to the upper right-hand corner of the screen, the Tribute lights are off. The radar that they're using to evaluate the density of birds in the area is showing some kind of blues and pale greens. So if you look down here to the key, relatively low density of birds is indicated by these blues and greens, and a relatively high density of birds is indicated by these warmer colors. So back up here to the top right screen, it's September 12th, 2015. It's 2:12 a.m. The Tribute lights are off, and radar is indicating there are about 500 birds within half a kilometer of the Tribute in Light in Lower Manhattan. Now, just below that, it's 20 minutes later in downtown Manhattan. The Tribute in Light spires are illuminated, and now there are an estimated 15,700 birds within half a kilometer of those Tribute lights. So what the researchers found was that generally when the lights were on, birds aggregated, and when the lights were extinguished, birds dispersed. They found that when the spires were on, the density in the area of the lights reached approximately 60 to 150 times the density of birds within half a kilometer when the lights were off. So, you know, a very extreme example of lighting. I mean, this is an enormous amount of light going 4 kilometers up into the sky. There aren't very many other examples of this, but this is not isolated and it's not new. I mean, we've known since the late 1800s that, oh my gosh, I've just totally lost the word for giant lights on the coast that are helping boats navigate. Birds have been attracted to those since the late 1800s, and ceilingometers at airports have been attracting birds since about the 1950s, looking at some mass attracting conditions. Much more typical is something like either of these two buildings. So the top photos here are the Standard Insurance Building in Galveston, Texas. Folks may remember it got a fair bit of media that in May of 2017, 398 birds collided with this building on a single night. 395 of them died immediately. 3 of them survived and were sent to rehab. And the good news was that the Standard Insurance Building elected to reduce their unnecessary overnight lighting for the remainder of migration season. You can see that there's still a fair bit of light on at this building, but it's much reduced from this facade lighting that they had prior to joining the Lights Out program. The lower photo is of the NASCAR Hall of Fame in Charlotte, North Carolina. Folks may remember this as well, that in October of 2019, 310 chimney swifts collided with this building. This is really like a 2-story building, so fairly low building, obviously quite illuminated. 97 of them died immediately and 205 were injured. So this is a much more average amount of light that we see on the landscape, and even this kind of thing is having an impact on bird populations. And you know, the question is, does it matter really? But what we know is that up to 1 billion birds die every year from hitting a window in North America alone. It's among the top 3 conservation issues for birds after habitat destruction and cats. And we also know from a report that came out of Cornell Lab in 2019 that we have lost nearly 30% of our North American migratory bird populations in about the last 50 years. So yeah, we know that our birds are in trouble, and these things that we can do to reduce hazards for them are really important, especially things like managing window collisions and managing light pollution. So I'm going to give you guys a little bit of whiplash for a minute, and we're going to talk about window collisions. There was a report, a study that came out in 2014 that looked at 93,000 collision records across the United States. And what they found was that 44% of collisions occur at 1 to 3 story residential buildings, and 56% of collisions happen at low-rise commercial buildings, so buildings under 11 stories tall. Very, very few, relatively speaking, collisions are happening at high rises. Now, that's not because high rises are not causing mortality. It's just that there are so many fewer of them on the landscape as compared to low-rise commercial buildings and residential homes. Most collisions are happening within the first 40 to 60 feet of the ground. That's where birds are spending most of their time foraging, nesting, flying around. So that's where they're most likely to encounter glass. And windows that are reflecting trees and vegetation and even reflections of sky are those that are most hazardous. Otherwise, see-through glass as well, transparent glass where there's habitat visible on the other side, is also hazardous for birds. But we know also that the presence of feeders and other attractants, including trees, increase the hazard. So there was a study done a few years ago looking at yards that had mature large-scale trees, and those had much higher incidence of window collisions than those that didn't have trees. So the moral of the story is not don't have windows and don't have trees and don't have attractants for birds in your yard, but definitely to look at managing the hazards so we can stop having this kind of impact on our bird populations. So when we talk about managing hazards, one of the easiest things we can do is turn off unnecessary lights that are attracting birds into our urban areas. Moving feeders close to the window is not exactly intuitive, but if a bird is sitting on a feeder and it's within less than 3 feet of a window, if it gets spooked off that feeder, say by a Cooper's hawk or another predator, it really doesn't have the time and space to accumulate enough momentum to run into that window at a lethal momentum. So moving our feeders close to our windows, keeping our cats inside obviously is a real help to our urban bird populations. And then using exterior insect screens is a very easy and generally cost-effective way to help reduce collisions. It dampens the reflection that birds see on the outside of the window. And it can also help kind of buffer the impact if they go ahead and fly into the window anyway. So if you're building new construction, I always encourage people to make sure you're getting exterior window screens that are also keeping insects out of your house. So it's kind of a win-win, and it's usually free with your windows. Apart from all of those things, marking the outside of the glass is what we really need to do to alert birds that there is a barrier in their way. So if you're using something that's, let's say, a relatively horizontally oriented marker, like a line or even a line of dots, these can measure no more than 2 inches apart. And if you're using something that's a more relatively vertically oriented marker, like again, line or a line of dots, they need to be no more than 4 inches apart. This is essentially the spacing that tells a bird in flight that is approaching your window that it can't fit into that space because there's some kind of a barrier there. So you're just interrupting the reflection. You can do all kinds of things like use Sharpie oil-based paint pens to draw on your windows. If you're very artistic, you can freehand it. If you're not, you can either hold something up to the back of the window and trace it, or you can use a projector to cast an image onto the window. I do this at home all the time. This isn't my drawing, but I do this at home. You can use decals, but they need to be very, very closely spaced, usually much more closely spaced than most people are very excited about doing. So we don't tend to recommend decals, but if you're willing to space them within 4 inches or so apart from each other, then you're good to go on that idea. There's something called Acopian bird savers that can be made custom designed for your particular window size. They're very inexpensive, but you can also go to your hardware store or go to Andy and Bax or another place like that and buy paracord, and you can actually make these yourself. It's just paracord that hangs down every 4 inches in front of the window, preserves the view out, and tells a bird that there's a barrier in the way there. So these are all really low cost options. You can also use more professional options. These are all retrofit, so aftermarket, but this is a dot pattern by Kaleidoscape that you can put on your windows. This is something called Feather Friendly, another dot pattern that you can use. And then there's something called Solix that has either a horizontal line pattern or a vertical line pattern, full coverage window film that you can buy. I don't recommend installing this yourself. You're really going to want a professional installer because it can bubble and it can be quite tricky to handle. So those are some ideas about how you can treat your windows to manage window collisions if that's an issue at your home or if you have a problem window. I'm happy to answer more questions about this. This was just a quick foray into what you can do about collisions. I want to talk about lights out alerts. So one really exciting tool that is being used by researchers at this point is radar technology. So essentially weather forecasting technology that is being used to track movements of birds. And birds have a unique signature as compared to precipitation or even insects. And so researchers can tell when there's a large movement of birds that is en route to our areas. And the Colorado State University Aero Eco Lab is now issuing lights out alerts. So they have red alert, orange alert, and yellow alert levels. And at Portland Audubon, we are broadcasting the red alert nights very, very heavily. Now, as folks probably know, migration is a very protracted process. So we're really talking about excess of 3 months in spring and excess of 3 months in fall. But most of our birds are going to move through during a peak period of about 1 month. And so if we can concentrate our efforts and really get people to manage their unnecessary lighting, at least during these peak periods, we're going to save a lot of birds. So this is a lights out alert that came out last spring, May 5th, 2021. It was a red alert for the entire state of Oregon, predicting 7.3 million birds flying over Oregon in a single night. And they break it down by city as well. Vancouver would probably be a little bit lumped in here with the Portland number, but essentially we were broadcasting this throughout the state. Everybody make sure that you're getting all of your unnecessary lighting off overnight. So it's a really amazing tool that we can use to get the word out. This is a really interesting research paper that was done by some folks in the Midwest. And what they did was they looked into the fact that there are some species that are nocturnal migrants that use flight calls while they're on migration. They likely evolved this as a way to facilitate collective decision-making while they're in flight. And so researchers looked at a 40-year record of collisions in Chicago and Cleveland. They had 70,000 nighttime songbird collisions in these two cities. And they found that of 93 total species that were in the collection, the species that are known to use nocturnal flight calls were overrepresented in the collection, and they called those super colliders. There's a long list of birds that make that list, and these are all in Latin, so they may or may not be recognizable to folks. But near the top of the list in terms of birds that we see out here as well, white-throated sparrow, dark-eyed junco, song sparrow, hermit thrush, Swainson's thrush, brown creeper, fox sparrow. So a bunch of familiar birds that are using these nocturnal calls. And what's happening is that birds that use these calls come into really lit areas. They start vocalizing more often, which is something that's been documented at areas with high light pollution. And they're inadvertently luring other birds of their species in to join them. And then there are these mass collision events. So a really interesting and pretty sobering paper. They also looked at reducing light pollution at the Field Museum in Chicago, and I think they found an almost 80% reduction in collisions on nights when that building was darkened, went lights out. So it can be very effective to get even individual buildings to go lights out. Obviously, it's much better if collectively we can get a lot of buildings and a lot of homes to go lights out. Okay, some research on short-eared owls and their prey species. What we know is that moonlight affects not only prey behavior, but also predator success. So in controlled like laboratory settings, owl hunting effectiveness improves with increasing available light. So it takes them less time to catch a mouse if they have more light, kind of obvious. But mouse activity is suppressed as an anti-predator strategy when they are subjected to more light. So under full moon conditions, mice are actually reducing their movement rates. They're foraging out, out from undercover for shorter periods. They're spending more time under dense cover than on new moon nights. So when we think about all of these streetlights that we're installing that are essentially like full moon every single night of the year, what kind of impact are we having on these long developed predator-prey relationships? This is a really interesting study that came out in 2018 from Meredith Kernbach's lab at the University of South Florida, where she captured a population of 50 house sparrows, a really common urban bird species, and she infected them all with West Nile virus. And then she split them into two groups. She had a control group of 25 individuals that she allowed to sleep in darkness overnight. And then she had a second group of 25 birds that she subjected to dim light at night. And what she found was that birds that were subjected to light at night had a prolonged infectious period beyond the birds that were allowed to sleep in darkness. So the birds that slept in darkness were infectious for about 4 days, after which their bodies brought West Nile virus down to sub-infectious levels. The birds that were exposed to artificial light at night, they were infectious for 2 or 3 more days beyond those control birds. And that means that if any of those birds that were subjected to artificial light at night were bitten by a mosquito during that additional period when they were still infectious, they would be able to spread West Nile virus to the mosquito, who could then go on to infect another bird. Or, spoiler alert, West Nile is zoonotic, so it also becomes a public health issue. And this team then modeled their findings, and they found an increased probability of 41% of a West Nile virus outbreak in the case of birds that are infectious for additional days beyond birds that could knock that virus out of their systems. So pretty interesting information that really does have public health impacts potentially. I don't know if anybody saw the 2018 climate science report. This was prepared by 300 federal and non-federal experts, and it was delivered to Congress. There was a chapter 24, on the Pacific Northwest. And what they predicted in that chapter was warmer temperatures, more mosquitoes, more West Nile virus, and more people getting infected and dying under a potential future climate change regime. So this was before Meredith Kernbach's findings were even published. So I think that this only serves to emphasize some of the concerns about what we need to be ready for under a climate change future and present, frankly speaking. Okay, sea turtles. I think this is probably one of the most famous examples of misorientation because of light pollution. I think most people have heard of this. But I want to mention it because a lot has been done to correct this. And so there is some good news. And I think that it is a good model for what we can do in terms of other light pollution impacts. But female sea turtles will use the Earth's magnetic force field to navigate to their natal beaches, and they will climb up onto dry sand. They will dig a pit. They will lay about 100 eggs in the sand, cover them up, and swim away. She's not coming back. Those eggs are going to incubate for about 60 days. And then the sea turtle hatchlings will group dig out of their nest. And then they have one job, and that job is to get out to the ocean. And what they are going to do, what they are programmed to do, is orient toward the brightest horizon. Now, evolutionarily speaking, in history, the brightest horizon would be the horizon over the ocean. Once you start introducing light pollution, the brightest horizon is generally not over the ocean, but actually upland. And so obviously a lot of sea turtles were misorienting uphill. Now, in many, many places around the world, this has been corrected by warmer lighting, dimmer lighting, very low profile lighting that's close to the ground to try to make sure that sea turtles can actually navigate out to sea, because really only about a quarter of these guys are going to survive anyway, but they just don't stand a chance if they can't get out to the ocean. So good news that we've really taken this seriously and that a lot has been done to correct that. Dung beetles are really much more amazing than I think most people have historically given them credit for, certainly much more amazing than I historically gave them credit for. But dung beetles actually have been shown to use the Milky Way in order to orient. And so what happens is they show up at a dung pile. It's a melee of competition, lots of dung beetles trying to get dung. They will roll themselves a ball. They'll stand on top of it and they'll take snapshots of the night sky. And then they will manage to roll a ball straight home. Researchers found that they could do this under a full starry night sky, and they could also do it in a planetarium where they were only shown the Milky Way. But if they were in a planetarium that had the Milky Way blotted out, they went in circles. If they were outfitted with a cap outside that didn't allow them to look up, they also rolled their balls in circles. So they need a view of the night sky and they need the Milky Way to be a part of that. But pretty amazing stuff that these guys, you know, probably about this, not even the size of my thumb, can use the Milky Way to navigate, right? Lodestar orientation in harbor seals. So these are animals that are traveling potentially very long distances without any terrestrial landmarks. And they've been shown in swimming planetariums to find a lodestar on the horizon and follow it until that lodestar dips below the horizon. And then they already have another star lined up that they can follow, and that helps them navigate. So also pretty amazing stuff. This is a Western red-backed salamander on the left that I found at the Oregon coast. And this is an Eastern red-backed salamander, only a species that's found back east. But what we know is that to avoid predators, salamanders and many species of frogs will actually restrict their movement on full moon nights, and they will hunt more and be more active on moonless nights. So ecologists at Utica College in New York, who are prone to working on Eastern salamanders frequently, they tested the effects of dim white light at night. So they were actually just using dim white string lights to see what kind of impact this would have on Eastern redback salamander activity. And what they found was that these amphibians that generally emerge from the leaf litter about an hour after dusk further delayed their emergence for an hour when there was even dim string lighting hanging over their habitat. So this restricts their activity time, it impacts their ability to feed, it impacts their ability to disperse and to successfully reproduce. So just thinking about even our home lighting, our backyard lighting, if we have amphibians out there, we can potentially impact them with even a relatively small amount of light. I realize this is really Oregon-centric. I suspect that there are probably a similar number of bat species in Washington as there are in Oregon. But bats are so cool. They're much maligned, unfortunately, but they really are pretty awesome. They're nocturnal and crepuscular. They're incredibly well adapted to very low light conditions, and they're really beneficial as insect eaters. So A single bat can eat 50% of its body weight in insects in a single night. And a lactating female can apparently eat 100% of her body weight in a single night. And then there are some bat species that are attracted to lights, especially for foraging. They're particularly attracted to lights that are concentrating a lot of insects. Bats that do this include the Yuma myotis and the California myotis. And then there are other species that are absolutely repelled by lighting. Lighting acts like a wall in their habitat, and Western pipistrelle is one of those. So when we are modifying the habitat of bats, we are potentially benefiting some, and we are creating a detriment to others. So just interesting to think about these really nuanced impacts that we're having even on whole taxa. Okay, so let's talk about insects. Now, we may not really care per se about insect declines, but declines in insect populations can actually have huge implications for ecosystem health and for things like our food systems because of crop pollination. So really something to think about. Some white LED lights have been studied and shown to attract up to 48% more insects than their high pressure sodium predecessors. So what these lights are doing is just creating a buffet of insects at these lights that are attracting then birds and bats to come predate on these insects, which may be good for the birds and bats. It may also be bad for them because they're subject to predation as well, but it's certainly not good for these insects. They're certainly not doing what they're supposed to be doing at night. And I took this photo at Timbers Stadium last summer. It really surprised me because I feel like in the Pacific Northwest, we pretty rarely see huge concentrations of insects. We're not a terribly buggy place in general, but I was surprised to look up and see where they had installed these new really bright white LEDs, that there was a huge concentration of insects up there. There was a study that came out of Germany in 2017 that showed that the biomass of flying insects has decreased by 75% in the last 27 years. And they found that there was evidence of a correlation to light pollution in this case when they mapped it. So really interesting work that's going on looking at insect populations. Let's talk about humans. So humans have non-vision forming cells in their eyes that are light sensitive, particularly sensitive to blue rich white light, like daytime light. And what this does is it suppresses melatonin secretion into our systems, and it tells our brains that it's time to wake up, that it's time to be alert, get some work done, and it impairs our ability to fall asleep. So this is the kind of light that's emitted by our cell phones and our computers, all of our devices really, but these come equipped with nightlight settings. In some cases, you have to turn them on. In some cases, they're factory set to on. But what they do is they dial that blue light down late in the day so that it's not actually suppressing melatonin secretion and you can actually sleep. This is the reason why a lot of sleep specialists encourage people not to go to bed with their devices at night or to wear red glasses that actually block the blue light from entering your eyes. But as I've kind of alluded to, many of our streetlights have been converted or are in the process of being converted to this kind of blue rich white light. So if you have a streetlight outside your house that shines into your bedroom and you're somebody that has trouble sleeping, it would be worth either requesting a back shield on that light from your local city or making sure that you have blackout curtains on your windows at the very least. You really don't want to be exposed to this kind of light late in the day. And I'll just remind you that the American Medical Association in 2016 encouraged municipalities to avoid the use of this kind of lighting when doing streetlight conversions because of concerns about relationships with cancer rates, diabetes, and cardiovascular disease. This is an interesting study that came out of the Stanford Sleep Epidemiology Lab. And it is a study that found that artificial light at night alters both sleep behavior and sleep quality. So they studied the habits of about 16,000 people for 8 years, and they found that areas that had higher outdoor night lighting levels were correlated with people reporting falling asleep later, having a decreased total sleep time, having lower sleep quality, and actually reporting symptoms that were consistent with something called circadian rhythm disorder. I mean, this is out of Stanford. This isn't out of some, woo-woo kind of study. This is Stanford Sleep Epidemiology Lab. So it's, I think, really something that is sobering and that we need to be paying attention to in terms of how we are impacting our own sleep patterns and our own health. I also want to talk about safety. We cannot get away from talking about safety when we're talking about how we design our outdoor lighting at night. We tend to think that more light equals more safety, but the data just doesn't actually support that. In fact, what we need is better lighting, not necessarily more lighting. So we need to be designing it more thoughtfully. Overly bright lighting, which tends to be the way that lighting gets designed in many cases, actually creates really deep shadows, which just creates places for, nefarious individuals to hide. It constricts our pupils when we're exposed to it, which actually impacts our night vision and impairs our ability to see into shadows, makes it harder when we're transitioning from areas that are really light to areas that are dark, which happens, honestly, in urban environments. We don't have light uniformity. So we need to be able to move from lighter areas to darker areas and not have there be such a huge gradient there. And it just basically blinds you to things in the shadows. So this is an interesting photographic comparison here. On the left, you can see that there is a light here that's unshielded. And when the photographer points it toward the back fence, you mostly see shadow here. The longer you stare at it, you can start to see that there's something there. But once the photographer holds their hand up to create a makeshift shield, all of a sudden, your eyes can better see that there's actually a person standing there in the shadows. So how can we make sure that we're designing our lighting more thoughtfully for safety and circulation? And the thing is, we just don't have to choose between security and safety on the ground and access to the night sky. This is just a small sampling of studies looking at lighting levels and public safety. And I want to draw your attention here to, one is the Chicago Alley Lighting Project. This came out in the year 2000 from the Illinois Criminal Justice Authority. And what happened in this paper was that they went in and they increased both the frequency and the wattage of lights in alleyways in various areas of Chicago. And then they looked at crime levels before and after that lighting change was made. And they actually found that crime increased 21% after the alley lighting was increased in frequency and wattage. So something to think about. It kind of turns on its head what we automatically think about safety and lighting. Yes, we absolutely need light, but do we actually need more, or do we just need better lighting? The other study I want to point to here is out of the National Institute of Justice, Preventing Crime, What Works, What Doesn't, What's Promising. And a direct quote from that report is street lighting an effective approach in the reduction and deterrence of crime? The answer is inconclusive. We have very little confidence that improved lighting prevents crime. So I think, there are more studies, and it is really interesting. Definitely this study down here out of Melbourne looked at lighting levels and found that areas that had really high lighting levels, particularly white light, made people feel more unsafe, and that people actually felt much more safe in areas that had layered lighting and warmer lighting. It also, when you have lighting like that, it reduces that really harsh transition from overlit areas to dark areas when they are adjacent to each other. So something to think about. Let's talk really quickly about equity and environmental justice. This is an emerging area of research on light pollution. So there's not a lot of research out there, but there's some pretty interesting stuff coming out. This first paper is called Cross-Sectional Association Between Outdoor Artificial Light at Night and Sleep Duration in Middle to Older Age Adults. And what these researchers found was higher levels of artificial light at night were associated with both very short and short sleep. Okay, we already know that. They found that associations between artificial light at night and short sleep were larger in neighborhoods with higher levels of poverty. So that's pretty sobering, right? I mean, we think about areas with more poverty, maybe more arterials, maybe more densely populated areas, higher density housing, probably with higher lighting on those arterial streets and higher lighting in parking lots, maybe less vegetation. All of those things are potentially contributing factors. What they recommended was that future studies should investigate the potential benefits of reducing light intensity in high light at night areas to actually improve sleep health. And then another study, Light Pollution Inequities in the Continental United States, a distributive environmental justice analysis. And what they found were disparities in exposures to light pollution depending on which racial and ethnic minority you belong to and in low to mid socioeconomic statuses. So Asian, Hispanic, and Black Americans were generally had twice as high levels of light pollution exposure in their neighborhoods than white Americans who are living in more affluent neighborhoods. Neighborhoods with higher proportions of Black, Hispanic, and Asian Americans or renter occupants had higher exposures to ambient light at night. And they found that this level of inequity was consistent across the urban-rural gradient. So a couple of really interesting studies. I think we're going to start to see a lot more research in this realm, and it's something to pay attention to, certainly in our urban cores. Let's talk about energy. So about 35% of light is wasted because it's poorly designed. That's because it's unshielded or it's poorly aimed. And this converts to about $3 billion a year of energy loss, which represents 15 million tons per year of CO2 emissions. So when we're thinking about low-hanging fruit in a time of climate change and what we can do to reduce our carbon emissions, well, reducing our wasted light at night should be considered low-hanging fruit, something we really need to think about. There are best practices in lighting design that have been developed. Minimize any unnecessary lighting. Make sure that your fixtures are fully shielded. Aim that light down. So here's a good example here of a fixture that is largely shielded and the light is aimed down. You see a lot of fixtures on public buildings, on private buildings, on people's houses, where there's light pointing in every direction. You're just looking at a glare bomb. So this is much better. Limit the total brightness or the total lumens. So how much light do you really need? Do you have to be able to perform surgery on your front porch? Or could it be just enough to kind of get your key in the door and get yourself safely around? So thinking about how much total brightness we really need. Choosing warm color is very important, as we talked about in terms of blue rich white light. So you really want the color temperature to be 3000 kelvins or below. And I think I have a photo on the next slide about how to identify that. And then whenever possible, using adaptive controls. So motion sensors or dimmers, so that you can have lighting dialed down when you're not actually active in certain areas around your house. Oh, maybe I don't have a slide, darn. I'll try to dig something up if folks are interested, but there are sometimes on the side of packaging, you will see that there will be something about color temperature. Sometimes it's vague. It will say something about utility room lighting, or it will say cool white. You really want warm white, and you want to look to see if you can find a Kelvin temperature rating and make sure it's absolutely under 3000 kelvins. 2700 is even better for any exterior at night application. So the bottom line question is, can we design our lighting in our cities and our parks and our green spaces so that we are simultaneously reducing light pollution, but we are still maintaining safe, vibrant spaces where people want to be? And I think the answer is yes. This is a picture from a park in Dallas, Texas, where there's some really nice trail lighting that just creates ambient lighting. The middle photo here is Amsterdam. There are a few glare bombs here, but they're really nice, warm lighting. And generally speaking, the area is fairly uniformly lit. It's very vibrant and inviting. This photo here in the upper right, the lower right, and the lower left, these are all the Highline Trail in New York City, in Chelsea. So if they can do this really nice kind of ambient lighting on a trail through New York City, I think we can do it any place else. We can do it in Vancouver, we can do it in Portland. Some more examples. This is the Prairie Line in Tacoma, designed by Place. There are a few glare bombs here, but they've also done some nice things with ambient lighting, dim string lighting, which we know still has environmental impacts, but it's certainly much better than overly bright glare bombs. And then some nice trail lighting as well. Vancouver, BC here on the right, and then in Houston in a park where there's some really nice trail lighting as well. And then I think what we really want to make sure is that we're not seeing visible light sources. Those create a lot of glare. We want to be creating a beautiful sense of place that has nice ambiance, that gives nice depth to the space, that does create wayfinding and visual direction when you're moving around an outdoor space that's comfortable, that has visual appeal. You want there to be cohesion in various parts of the landscape, but you want it to be really nice, low lighting. So here are some examples of good exterior lighting. Now, obviously, once you go to bed at night, do you need to have all this path lighting on? My answer would be no. But do what makes you feel safe at home, but certainly consider having low lighting and warm exterior lighting. Here's some nice subtle trail lighting, some nice well-shielded lighting on the side of a house. So no glare bombs, no visible light sources, no bright white lighting. And I just want to give a plug. I know I'm getting to time here, but Portland Audubon has a program called the Take the Pledge to Go Lights Out program, where we ask people to look around their homes for opportunities to reduce any unnecessary lighting at night. Also to make sure that your lights are pointed down, that they're shielded, or that they're on motion sensors. And you can enroll in this program. We'll mail you a metal sign that you can put in your yard, and then watch for lights out alerts during peak migration on our social media, or you can go to the CSU Aero Eco Lab and look for their published alerts every 3 days. Here is the image that I was looking for in that last slide. So here the color temperature is clearly marked 3000 kelvins, and it's a 12-watt LED. Now, watt doesn't mean what it used to mean when we had high pressure sodium. This really just speaks to the energy efficiency of the bulb. But I can tell you that 12 watts is still very bright. I have this, it has a motion sensor at the tip of the bulb. I have this on my front porch. It's much brighter than I need. Really, probably 8 or 9 watts would be sufficient. This was the lowest one that I could find. And this Aquara light is available on Amazon. So enroll in the Take the Pledge to Go Lights Out program and think about your home lighting, talk to your neighbors, talk to your friends, help spread the gospel that we need darkness. And that's all I have. If folks have any thoughts or questions, I'll stop sharing my screen.
Mary, thanks for the presentation. So there are some questions in the chat if you want to read them and answer them, or if I could read them as well, or you can answer them, whichever you'd like.
Lighthouse. Thank you, Sam. I don't know why I just had suddenly a mental block. I could see a lighthouse in my mind, but I couldn't come up with a word. How are you broadcasting the red alerts? Generally speaking, we are putting them on our social media networks. So we put them on Instagram, Twitter, and Facebook. I'm also sharing them with Audubon chapters around the state so that they can broadcast them as well. Unfortunately, they are only published for 3-day increments. So we don't get a lot of warning. It would be wonderful if we had weeks of lead time on this, but we just don't. So you really have to stay on top of it for the entire month. Yeah, mid-April to mid-May. I'll try to contact Timbers and Thorns owner Merritt Paulson about stadium lights. That would be great. I think Merritt Paulson has some really big stuff on his mind right now. But if he wanted to think about the lighting, that would be amazing. You know, the most important thing is that it really stays concentrated on the field and that it's turned off as soon as that game ends and people are out of the stadium. Somebody asks if the presentation is available. Yeah, I can absolutely share it with Dawn or Sam and they can make it available to other people. I'm happy to share it. Any ways to get this information out, I'm happy to do it.
We actually just, so we record the meetings. And so we put those up, they're up on Facebook, so you can actually rewatch them if you would like the information. And we also have, I'm not sure if we've quite put anything public yet, but we're working on a YouTube channel that will also have our presentations up there. So all this information will be available to the public. Yeah.
Good. Yeah, and hopefully Vancouver Audubon Society will also share red alerts during peak migration season on their Facebook page. Which part of city governments makes decisions about lighting? Are there building codes? Yes, there are building codes. It depends. I mean, I can't speak to the city of Vancouver. In the city of Portland, yes, there are building codes that do govern the way that buildings are lit, but there is also city street lighting. There's also sign lighting. So there are various places where lighting is governed. And in some cases, it's in a comprehensive plan. In some cases, it's really distributed. Some cities have developed specific lighting ordinances that address all forms of lighting. So it really varies. In the city of Portland, it can be PBOT that we're dealing with. It can also be the Bureau of Planning and Sustainability. So it does vary. And then each bureau may govern their own lighting. So you have to get it into the city's own green building policy that governs the way that they design their own lighting. I'm not intimately familiar with the way the city of Vancouver is run, and I haven't worked with them on lighting code, so I can't answer that question specific to Vancouver, but we could follow up on it. Feel free to send me an email if you're interested in pursuing it. My email address is mcoolidge, M as in Mary, COOLIDGE @audubonportland.org. How can we reduce window strikes from glass day or night? So I gave a very quick blurb on how to reduce window strikes during the day. There's more information about that on Portland Audubon's website. If you were to Google tips for reducing window collisions, Portland Audubon, you would get to our tips page, and there are all kinds of ways that you can do it. It can be anything from painting with tempera paint, painting with oil-based Sharpie pens, putting lots of decals all over the windows, which isn't the most popular idea, using dot patterns that are distributed across the entire window, line patterns. You can use full coverage window films, or you can use films that just leave whatever the marker is and nothing else on the window. Moving your bird feeders to within 3 feet of the window really helps a lot. I know it's counterintuitive, but birds just don't have the momentum they need to hit the window if they're spooked off of a feeder that's really close to the glass. In new development, there are a whole other set of approaches, including fritted glass, acid etched glass, UV patterned glass. But those are really not aftermarket solutions that we're talking about at people's homes. Nighttime collisions are much less frequent, except on large buildings or buildings that are very lit, like we talked about with the Standard Insurance Building or the NASCAR Hall of Fame, and that has to do with lighting. So for sure, drawing your blinds during peak migration season so that you're not creating unnecessary light trespass that creates a bunch of sky glow that ends up drawing birds into cities at night. So that's just a real quick brain dump. The website, if you Google CSU, Colorado State University, CSU Aero Ecolab, AERO-ECO lab, you'll come up with it. I don't know exactly. It's something like, let me put this in the box. It's something like that, but that's probably not exactly right. So I would recommend, oh, good. There we go. Yes. Thank you, Sam. What if the buildings with glass are restaurants, office buildings, not my home? I mean, we do have an outreach campaign where we ask building owners to turn off their interior lighting overnight. One of the problems is that a lot of buildings employ overnight cleaning crews. And so even if the building has converted to motion censored lighting, they may have cleaning crews inside them at night that are triggering those lights to come on. And then that is creating an attractant to that building. So generally speaking, asking buildings to turn off that interior lighting, asking them to draw shades or blinds if they have them, even asking them to schedule their cleaning crews to operate during the day. Like US Fish and Wildlife, if you go to their building in Lloyd Center, all of their cleaning crews are actually operating during the day, just so they're not triggering those lights to come on overnight. So things like that. And then, you know, in commercial buildings, we do see a lot of retrofits with full coverage window films where they have a collision issue. But again, that's going to be more of a daytime issue because it has to do with reflections or transparency in the glass. I think I've come to the end of the questions.
If there are no more questions, thank you so much for the informative presentation, Mary. It's really nice to hear about all the impacts that we have as people on our environment and the birds in it, and then how we can mitigate some of those impacts, the negative ones.
Yeah. Well, I appreciate everybody's attention tonight, and get in touch if you have questions. And I hope to continue working with Vancouver Audubon Society in the future.
Yeah, we love partnering with Portland Audubon, so
Thank you, Mary.
always open.
Thanks, Dawn. Thanks, Sam. We'll be in touch.